All right, so the next shortcut that we're going to look at is angle side angle, or ASA. If two angles of one triangle and the side in between those two angles are congruent to two angles of another triangle and the side in between, then those two angles are congruent. So let's look at what we've got here. We've got a 68-degree angle and a 68-degree angle. We've got 42 and 42. So we've got two angles that are congruent. And so now what we need is a side in between those two angles that are congruent. And that would be that 10 centimeter side. So if we were looking at triangle ABC, that would be the 42, 68, and then the unlabeled side. That would be congruent to triangle EFD. So ABC is congruent to triangle EFD. Now, in this example, how do I know that the side is congruent? How do I know that? Well, let me get this ready. How do I know that's congruent? The triangles share the side. And so if it's the same, if they're sharing it, it's going to be the same measure in each triangle. Now, you actually learned about that property in algebra, and it was called reflexive property. That's basically saying that something is equal to itself. NS is equal to NS or congruent to NS. Okay, so the reflexive property tells us that something is equal or something is congruent to itself. So I've got NSG. So NSG. So then if I'm going to have a congruency statement here, I'm going to have NSW. That would be how I would name my other triangle. And again, this side right here in between those two angles is congruent. Our fourth shortcut is angle, side, or AAS. If two angles of one triangle and one side that is not between those two angles, so a while ago the side was between those two angles, this time the side is not between those two angles, then it's going to be congruent. So here I've got angle S congruent to angle T. Then I have angle W congruent to angle P. And then I've got that side. And that side is after that second angle. Okay? This one can be a little bit harder to spot. I think out of all of the ones, this is probably the one that can be the most difficult to spot. So QPT. QPT is congruent to RWS. QPT is congruent to RWS. And one more example. Again, how do I know that these angles are congruent? There's nothing marked. Right here at angle M. Angle M has vertical angles. I told you guys that vertical angles would become very important in geometry. Vertical angles are congruent. So, we've got L. I've got something left off here. Oh, how else do I know? Because I'm looking for angles. Do you see these marks? Remember what these marks mean? Those marks, those arrows, those do not mean that they're congruent. Those little arrows like that, arrows mean lines are parallel. So if lines are parallel, I've got some other angles that are going to be congruent because of parallel lines and transversals, right? N and P would be congruent, and L and O would be congruent. Okay? So I got a lot of things going on now. So LPM would be congruent to triangle ONM. So triangle LPM is congruent to triangle ONM. So because of the parallel lines, I can say angle N and angle P are congruent, and L and O are congruent. Those are alternate interior angles, both sets. L and M, should we write that down? Probably. Angle N and angle P are alternate interior angles, and angle L and angle O are alternate interior angles. That's why I can say that those angles are congruent.